will look laterally. So this is going to, so for this one, so this is my right eye, this is my left eye, right? So the right is going to lateral rectus. Okay. What about the left eye? What's the left eye going to do? The lateral rectus going to contract look laterally? No, the medial rectus is going to contract, right? So it's going to look medially. The left eye is going to be medial rectus. Okay, so that was the one thing that was confusing, was why the two different eyes are using two different nerves and using two different muscles to do what seems like one thing, right? And it's because on one side of your body you're looking, even if you're looking, you know, to this side, right? That's lateral on one side of your body and that's medial on the other side of your body. Okay? Does that clear up some confusion for everyone? All right, the other thing that was confusing, and I don't have the book in front of me, was when you are sitting in your chair or your eyeballs are sitting in your eye socket. Yes, ma'am. Would I like you to learn all the muscles? Yeah, I mean the muscles of the eye are pretty easy. I mean, it's just there's lateral, superior, medial, inferior, superior, inferior. The muscles like that. What all the muscles do, you should be familiar with it. I don't know that you need to know all of the combinations. I'm more telling you in case you were looking at it so that you don't spend hours trying to decipher it. So the other thing was, if when you're just sitting there or when your eyes are sitting in their socket, right? Even if you're just looking straight ahead, right? There's some muscle tone in all of the muscles, right? That are just sort of stabilizing and sort of holding things where they're at. Okay. So that if you knock out a muscle, right? If that muscle is gone, then the eye's going to drift in that direction. Okay. So that was the other thing that was talked about in that sort of table, and then in the blue boxes. And so if you knock out the trigeminal nerve, or you knock out the trochlear nerve, yeah, Dussen's nerve, sorry, if you knock out the Dussen's or you knock out the trigeminal, right, what's going to happen? And similarly, you can think about what's going to happen if you knock out the capillary motor. Does that, everyone understand that? How it all fits together? Okay, good. So, I told you today that we would pretend that we were going to work through the lab manual, right? Because there's no endocrine system in your Vortex, right? So this is the only endocrine system that we have, right? Okay, so if you flip through this, you can quickly see that none of the things I put on the slides on Monday are in there. Okay? So the first thing that I would do is I'd probably curse out Dr. Nelson. Then I would be like, all right, well, okay, so how does this fit together? Like, what do Dr. Nelson's questions look like? What is he possibly going to ask us on the reason? Right, after I calm down, right? Maybe watch some bad cartoons or something and drink some, strawberry milk or something like that. All right, so here's the rest of what's going to be on chapter 4. Right? So there's going to be sort of the endocrine system, and this is what I just got upset about. Then we're going to do the respiratory system, we're going to do the digestive system, the reproductive system, we're going to do back anatomy, and upper and lower extremity. Right? And I'd say, okay, well, Dr. Nelson likes to put things together, so what of these things could we possibly put together? Right? Okay, you put together the endocrine system with back anatomy, upper and lower extremity. Probably not. Right? Let's nix those. Right? What about endocrine and respiratory, or endocrine and digestive, or endocrine and reproductive? Right? All of those make sense, right? We already talked about the link between this and this. have some semblance of why Dr. Nelson may talk about what he talked about. So the back anatomy and the upper and lower extremity, right, they don't have clear links that we can think about at this point with the endocrine system. It's still on the fourth exam, right? But if we're thinking about putting together questions and how is Dr. Nelson going to construct something, how should I study, how should I formulate my thought process, right? That shouldn't be, hold off on that, look at these other things. Yes? The back and upper limb would be for more, yeah. And so the respiratory, right, so we'll look at, I'll give you some slides for respiratory and then we'll finish up the thoracic cavity, look at some digestive stuff, we'll finish up the abdominal cavity, and then we'll look at some reproductive stuff and we'll finish up the peritoneal cavity. So the digestive, so the anatomy you can do more, and then the sort of function and endocrine part we'll have to get to. All right. So that's all of that, right? So then, all right. So then we look. So now we sort of have a new focus. So if we look through this, what possible pieces of information would Dr. Nelson pull out of exercise 19? It's only. And as a student, I always count the pages, right? It's only, what is it, 14 pages? It's not a lot of material, right? Yes. In the manual, it's 19, exercise 19. And some of this is super small stuff, right? Some of this is specific cells. Looks more like histology, right? And some of this is big, gross stuff. Right? All right, so the first figure is a figure similar to what Dr. Nelson showed us on 343. So you have the pituitary gland, the pineal gland, the hypothalamus, the parathyroid, thymus, thyroid, adrenal, gonads, and pancreas, right? So they're probably all of the organs that are going to be covered in here. Yes?
I got one more question about the fourth exam. Well, the syllabus says that the back anatomy and the upper extremity and lower extremity until the final.
Oh, yeah, we can. That's fine. We can do that.
Okay. Make sure.
Sure. And then, so that's all fine. So, and then there's not much else on there, right? It talks about hormones. We talk about hormones. It talks about endocrine glands. It talks about neuroendocrine effects. That page is done. All right. So now on to the next thing. So it says there's this pineal gland, and it wants to know what the function of the pineal gland is. Did Dr. Nelson talk about the pineal gland? No? Yes, he did. Not on the endocrine system, but he talked about it previously, right? He talked about it previously when we talked about the brain. Yeah, and the tectum, right? All right, so that's probably important. Do we remember from studying for the third exam, which we're currently doing, what pineal gland does, what it's involved in? Melatonin and light dark cycles. All right, so that's good. We got that done. Then the next thing is the hypothalamus. Right? We didn't talk that much about the hypothalamus, but the hypothalamus, underneath of it, it has two things. It has ADH and it has oxytocin. Okay. Does anyone remember what ADH does? ADH stands for antidiuretic hormone. Keeps the water in, right? So is that going to be important for any of these other things we might be talking about in the future? Yeah, the digestive system and the kidneys, right? So hypothalamus is probably going to be important, right? And oxytocin, does anyone remember anything that I talked about with oxytocin? Yeah. Birth, right? So contraction of the smooth muscle in the uterus, right? So that's important for there. It's also important, so there's also, I forget if it's in your book or someplace else. So oxytocin, when I was in my PhD, I argued with one of the other instructors vehemently about the function of oxytocin. They said all it does is contraction of the uterus. I was like, no, it contracts the muscles around the mammary glands. Turns out we're both right. So oxytocin is important in both the rhythmic contractions of the uterus during childbirth, and then post-childbirth, when the baby cries. Sometimes when the baby cries, the mother lactates even though there's no like physical contact with the baby, right? And that's because there's a reflex arc. Yeah.
So the hypothalamus, that's responsible for releasing hormones?
That's yeah. So it'll release and it'll send both activating and inhibiting hormones. But the ones that are listed in your book are ADH. So all of these have like ridiculous numbers of things, right? And you're not, again, you are not an endocrinologist. I'm not trying to train you to be an endocrinologist. Right? We're just trying to hit the highlights, right? So it contracts both. So if this is, and we'll do this in reproduction, right? So this is the nipple, and then this is the breast, right? And then you have, inside of here, you have ducts, right? They come out. Right? And those ducts go down to something that looks like your lung tissue, right? It has like these bulbous things on it. Around those bulbs is a smooth muscle. Oops. Right? And this is this sort of ring-like muscle is what contracts and sort of allows the milk to come out of the nipple, right? And so there's two ways that can, so crying will sometimes, if a baby cries and not an adult cries, that will cause the release of oxytocin, which will cause this to contract, and there'll be milk production or milk release, right? Also a suckling response, right? So if there's a physical response, the baby suckles on the breast, right? That's the stronger cycle that causes these to contract. All right, so that's oxytocin. So now we're a little ahead of where Dr. Nelson currently is. Right? All right, then we have on the next page, oh yeah, we did talk about this on Monday, right? We got the Cella turcica, which you guys need to know for lab, right? Hopefully everyone knows that. And then inside of the Cella turcica is what? The pituitary gland, right? And there's two lobes to the pituitary gland.
Anterior, posterior.
Anterior and posterior, right? And one of those is primarily neurological, and one of those is primarily hormonal, right? I talked about that briefly. I sort of blew through it as an example of neuroendocrine and how a neuron will interact with another neuron to release hormones. And your book talks about this. The manual talks about this a little bit, right? The one thing that it has on here is TSH, which is thyroid stimulating hormone. What, by God, do you think thyroid stimulating hormone would do? It stimulates your thyroid, right? That's an easy one. Hopefully you wouldn't get that wrong. So the thyroid stimulating hormone stimulates the thyroid, and then what's the thyroid going to release?
T3, T4.
T3, T4, right? And it's going to be for metabolism and growth. Then you have something that you probably didn't hear of. There's the adrenocorticotropic hormone, or ACTH. Right? What do you think the adrenocorticotropic hormone would be involved in? Adrenaline, right? And we haven't gone through the adrenal glands yet. This is another hormone that's going to target another endocrine gland. Right? So this is being secreted by the pituitary. It's going to go to the adrenal cortex of the adrenal glands, right? And it's going to release glucocorticoids. Right? What do glucocorticoids sound like? Is that an amine? Do you think it's fat soluble or not fat soluble? So is it a steroid or is it something else? It's a steroid, right? Which means that it's going to have big effects, right? Then we have, the next one down is we have the gonadotropins. Gonads, hopefully, from your adolescent days and pre-adolescence, right? That sort of should respond to serious humor, laughter, and giggling, right? soon as you hear gonads, you know what we're talking about. Okay, so there's two different ones, right? There's follicle stimulating hormone, right? And then there's luteinizing hormone. Right? So the follicle stimulating hormone, what's that going to be most useful for? Does anyone know? What's that? Hair growth? Oh, follicle for the hair follicles. We're in the gonads. Yeah, you know. So we're in the gonads. So follicle stimulating hormone. It does have to do with growth, not hair growth. What is growing in your gonads? Sex cells, right? The gametes, sperm and ova, right? So it's going to have to do with the maturation and proliferation of those two things, right? And the release. What about luteinizing hormone? This is one you may not be so familiar with. So so again, we're getting way ahead of where I'm currently on the slides, right? So in the ovary, right, and we have the fallopian tubes, right? You have ova in here. Every 28 days, one of those ova is chosen to be the mature ova, right? And go to fruition and be released and sent down the fallopian tube, right? So that all is controlled by the follicle stimulating hormone, right? But now you have around this, right? You have this other stuff, okay? The ova isn't just like, there's not just like this egg that just gets like thrown out, right? There's other cell structures around it, right? Those other cell structures around it need to be broken down. So part of the secretion process and part of the breakdown of this is done by luteinizing hormone. So after the egg is released, the body or the cells that are left behind is called the corpus luteum, right? Which is how I always remember the link: luteinizing hormone, corpus luteum, corpus luteum. So corpus, you just think of a body, a corpse, right? And then luteum, I don't know why it's luteum, but that's what it is, right? Luteum, luteinizing hormone. Okay? And this is generally what my study notes look like. They're a total mess. And then someone who's very organized comes in and is just like, and they systemize it for me and put it on some nice index cards. Then I have a better study going. All right. Then you have prolactin. Milk, right? Production of milk. So it's going to affect the mammary glands. It's going to cause milk secretion, right, or milk production. Right? And that ties together with oxytocin. So at that point, I would probably try and make some sort of link between those two things, right? Because the mastery of vast amounts of information is putting things together. Right? If you're trying to study everything in isolation, you have 1,000 terms. If you can put all 1,000 terms in boxes of 10, and you have 100 terms, you can put those in boxes of 10, now you have 10 terms. Right? And then you unpack that one box, and then you get the other stuff. Right? That's how you get it in your brain, that's how you recall it. That's how the masters are successful. Okay? So you have prolactin. Then the other thing that's listed is you have growth hormone, right? Growth hormone, that's pretty obvious. Growth hormone is involved in growth, right? It's going to have multiple targets. That's not so hard. Melanocyte stimulating hormone. This is a weird one. I would say this isn't exceedingly important because it's targeted somewhere in the brain. It produces melanin. It's currently unknown what it really functions in. Right? So it's not going to be that. I'm not going to ask you a whole lot about it. Right? It could have ties to the substantia nigra, which is the darkest body in the darkest cell structure, I should say, like a celestial body, darkest body in your brain. But that's just me, like, putting two things together that may really go together or not. Okay. All right, at the bottom it says making connections. So it says a pituitary tumor can have widespread effects on endocrine system function. Explain why. So does that seem like something I could possibly ask you on an exam? Yeah, right? So that would probably be something that I would try and think through. Right? And it's not going to be that complicated. Right? If you have a pituitary tumor, right, it could affect any of those hormones that we just talked about. Right? So to make it a more specific and more difficult question for you, other than is a pituitary hormone good or bad, right? What if we said, if you had a pituitary hormone at this stage of your life, right? If you had a pituitary tumor when you were a child, right? Which one of those hormones is going to be most affected? Right? The growth hormone, thyroid stimulating hormone, right? All of those are going to be important. If you had a tumor during puberty, right, it's going to shift, right? Then everything's sort of somewhat important, except for prolactin, right? Because you're probably not lactating at that point in your life, right? But everything else is still going on. You're still growing to some extent, right? You're still, and now you're also starting to go through puberty, so you're starting to produce sperm, your ovaries are starting to cycle, right? So all of that's now coming into play, right? If you had a pituitary tumor when you were, you know, whatever, post-menopause, or when you're 60 or 70, right? A lot of these aren't going to be super important, right? Because you're already done growing by that point, right? Your reproductive cycle is sort of down, you're not lactating, right? So, I mean, it's still bad, right? But it's not going to have this big of an effect on your whole body, or on your endocrine system. All right. Any questions about that? We spent a lot of time on 19.1. There's a lot of stuff. No? Okay. So then the next one is talking about the thyroid gland and the parathyroid gland, and now you sort of recognize that there was a picture that I showed you previously. And this all looks fairly familiar. Nothing really new on here. It talks about hypothyroidism, which is the overproduction of the thyroid gland, thyroid hormone T4, T3. Dr. Nelson talked about the hypo, not the hyper, but we have to still ask a question about it, so that's probably important, right? And then below it, it says there's two pairs of pea-sized parathyroid glands embedded on the posterior surface of the thyroid gland lobes. They produce parathyroid hormone. Parathyroid hormone opposes the action of calcitonin by increasing the concentration of calcium ions in the body. Right? So we don't know where the other side is at yet, right? But there's this opposing thing. Was there anything that Dr. Nelson talked about on Monday about opposing? Is there a key word that I would know that he might put on the exam and it might trip me up? Antagonism, right? Hormones can act synergistically, they can act sort of permissively, or they can act antagonistically. Right? So this is probably a good one to know for antagonism. Right? All right. And that's pretty much it for that one. And on the next page, it talks about the thymus gland, T lymphocytes. We didn't talk about the immune system. The immune system is not something that we're going to cover, so we probably don't need to know that in great detail. It says something about the heart. We already covered the heart. Maybe that'll be on the final. I'll deal with that later. So calcitonin and PTH, so making connections. Calcitonin and PTH regulate the concentration of calcium ions in body fluids. Why do you think it is important to maintain calcium in the body? So does one of these things produce calcitonin? One of these, we missed calcitonin somehow, right? Oh, I found it. We blew through it. right? So it's one of these two organs. So is it the thymus or is it the thyroid? The thyroid, right? So the thyroid produces calcitonin, the parathyroid produces the parathyroid hormone, which antagonizes it. All right, so the question is, calcitonin and PTH regulate the concentration of calcium ions in the body fluids. Why do you think this is important? You need calcium for everything. Muscle contraction, bones. Yeah, so calcium is important. Calcium is an important signaling protein, right, in your bones, it's in your muscles. So what do you think would happen if calcium concentration went down in the blood supply? Right, what if you just started urinating or defecating large quantities of calcium because your body all of a sudden decided that it didn't want that high of a concentration in its blood flow, and so it's just going to filter it out a little bit. Think that would be healthy? No, not a good plan, right? What do you think is going to happen in your body? This would be a good final exam question. Yes? Your bones will get brittle, also known as osteoporosis, right? So you're going to lose bone density, right? Calcium is going to leak out, your bones are going to become brittle, right? Things are going to leak out. Okay? So that's how, if everyone didn't follow that, that's how a final exam, that's how I would think about a final exam question, right? Is what do we learn at the beginning that can be tied into something that we learn later on, and how can I weave that together in a question that's approachable for you and answerable, right? I could give you some crazy case, right, where someone comes in and there's like 10 different things wrong. But you're not going to solve that. It's insane. Right? I couldn't solve that. I couldn't write that. I wouldn't solve it. All right. Moving on. So then we have digestive organs. Oh, this looks good. So this is the stuff we haven't covered yet. You got the stomach and the small intestine. They produce several hormones. We don't know what they are yet. And then we're going to, this is all about dissection. Then the head of the pancreas is nested in a C shape. We don't care. Body pancreas, we don't care. All right. Finally, the brownish box at the bottom. The pancreas is largely composed of glandular tissue, pancreatic islet cells. Oh, here we go. Glucagon and insulin. What are those involved in? They're antagonistic as well, right? And they regulate glucagon, sounds like, so does anyone know glucagon? Or insulin is probably the key word, right? What's insulin involved in? What do you know about insulin?
Increases blood glucose.
Increased blood glucose, right? People that are diabetic are going to take insulin, right? So it has something to do with glucose, right? So glucagon and insulin are going to balance your glucose blood sugars, right? And the fact that you linked it to increase in blood sugars, linked it to diabetes, right? You can start to formulate what a question would look like. Right? How would Dr. Nelson phrase this in a question? A person came in with low blood sugar or had X symptoms, and you think it might be low blood sugar. What would you test? Right? Or what could possibly be going wrong? Right? So that is your, and then there's other things in the stomach, right, that are secreted that we'll talk about later on next to the digestion. They don't talk about it here, I don't see. They talk about type 1 diabetes, type 2 diabetes. The key difference is one's genetic and one is contracted by lifestyle. It's moving into one of the top pillars of the U.S. population. The adrenal glands produce and secrete several types of hormones. All right, so here we go. So here's, you got the adrenal cortex, you got the adrenal medulla. Oh, it doesn't tell us what's in each one. And then we got the kidneys. Right? And the kidneys are linked to the parathyroid hormone. They release a hormone called calcitriol, which acts on the small intestine to increase the absorption of calcium and phosphate. so now, if I was doing this for real, right, if I was you, I would have, so here's my thyroid, here's my parathyroid, right? And so then I would list out what the hormones were here. Oh. So there's parathyroid. Hormone. Maybe there's calcitonin. And then, is that right? Yeah. So these fight each other, right? I would probably make some symbol for fighting. I would make it whatever is going to stick in your brain, right? Right? And that's about regulating calcium in the blood. Okay? And then this is going to act on it's going to act on the kidneys. Right? So I could draw some sort of thing here, right? And the kidneys are going to release the calcitrol. Right? And this is going to act, however you want to draw your small intestines. Right? It's going to act on the small intestines to absorb calcium and phosphate. Right? And that's very messy. Right? You guys will do this much better than I do. But that's sort of what I would do. Right? I would take those various pages and I'd put them together in some sort of organized fashion and make a map. Right? Because otherwise it's like you have this piece of information here, you have this piece of information there. Right? So you have to link it together. If you don't link it together, you're never going to be able to put it together. When I ask you a question about, I block some calcium uptake channel in the intestine, what's going to happen? Or what's going to, is the release of calcitrol going to go up? Is the release of parathyroid hormone going to go up? Is calcitonin going to go up? Or is some combination of these two going to go up? Right? Or all three of them are going to go up in concert? Right? That would be a good question.